On July 20th, 1969, 3 astronauts flew 3 days to the moon. When they got there, 2 astronauts, Neil Armstrong, Buzz Aldrin, got into the lunar excursion module called a LEM and made their way down to the moon. The journey took another 2.5 hours. It was apparently a lot harder than they expected. With only 40 seconds worth of fuel, Neil lands the LEM on the surface of the moon. Michael Collins orbiting the moon, waiting for their return. Shortly after they landed, Armstrong left the LEM and makes the first step on the moon. That step, one small step for man, one giant step for mankind. Shortly after, Buzz Aldrin makes his way out of the LEM and very carefully, without locking the door, the hatch, because as it turned out, they never designed a door handle on the outside, makes his way out of the LEM and down the stairs. What you're looking at here is that seminal photograph that was taken by Neil Armstrong. A seminal photograph taken by Neil Armstrong of Buzz Aldrin as they landed on the moon, as they stepped onto the lunar surface of Tranquility Base. Tranquility Base. Well, those photographs came back to Earth, and of course, to this day, still takes my breath away thinking about it. It was a step for man, but surely a giant step for mankind. But those photographs came back, inspired hundreds of millions, but at the same time, caused many people to be quite excited about whether the origin of this photograph was truly from the moon. There was good reason for them to question these photographs. First of all, when you look at that image of Buzz Aldrin, and you look at the shadows on the ground, the dark shadows.
Something stopped in the past that we wanted to keep it going, but I think I know. Because we didn't. And
first of all, when you look at that image of Buzz Aldrin, and you look at the shadows on the ground, the dark shadows, he's surely in shadow. If he's surely in shadow, because the sun is on the other side of the LEM, how is it possible that he is that bright? Second, we know there's no atmosphere on the moon. And if there's no atmosphere on the moon, we should be able to see the stars. Clearly, they knew that we could very easily, through the positioning of the stars, determine whether they were actually on the moon. And the belief is that it must have been too complicated to line those up, so they decided to leave them out. It is possible that this photograph was taken here on Earth. Now, with the invention of VXGI, and through the extraordinary efforts of our engineers, we meticulously model the lunar limb. Here's the wonderful thing about the lunar limb. It's made out of aluminum foil, cloth, and a generous application of tape. It was a flying Coke can. No wonder Aldrin and Armstrong wanted to get out of that thing as fast as they could. It was a flying Coke can. We modeled every detail. We had to model every single detail. We modeled the surface of the moon so that we could start to study and test these mysteries and come to our own conclusion through scientific means whether it is possible, whether they did land on the moon. Ladies and gentlemen, I'd like to demonstrate to you guys now our work. Every single little detail. Now, first of all, come on, fess up. You thought that was a photograph, right? That was a photograph. You thought that was a photograph. The first time I saw it, it was rough. But by the time I saw the final works, I thought it was a photograph. It's really amazing work. The engineers modeled every little detail. And so let's go through and let's test each one of those conspiracy theories. The first one is this. Curtis, let's go to, let's assume that he is in shadow and that the only light source is direct. Well, this is what it would look like. This is what Buzz would, and this is what people expected him to look like. And the reason for that is because the sun is on the other side of the limb. And you can also see the shadows on the ground are perfectly dark. So how is it possible that he's lit? Well, as it turns out, we modeled the entire surface of the moon. We modeled the dust particles of the moon, and we learned this. We learned that the dust particles on the moon, which is created obviously from asteroids bombarding the moon, okay, relentless over billions of years, it's fine particles, and it in fact has reflective properties. Now, the reflective properties are not great. It only reflects about 10, 12% of the light that hits it. However, as in many type of dust particles and crystals, when a light hits it directly and you look at it from the same angle as the light source, the reflected light is multiple times brighter than it otherwise would have reflected. It's a phenomenon called opposition surge. Well, we simulated the properties of the moon dust, and as you can see, right now, the sun is behind me, the limb is beside me. Notice the brightness of the sun as it's reflecting off the lunar surface. Well, suppose we were to turn on VXGI, and we turn every single surface into a light source so that it reflects the light. Let's see what happens. Well, voila. Reflecting off of this lunar surface, the sun was able to light Buzz Aldrin. Well, that's mystery number one. Mystery number two is this. Why is it that while we're looking at him right now, we don't see the stars? Well, that's a simple answer. Turns out it's a simple matter of exposure. The light is so bright, in fact, that they had to change the exposure of their camera to the point where you're not over blindingly bright on the surface of the moon, while therefore you're no longer able to see the stars. And so what we did was this. In fact, when we look out into into the sky, we've modeled all 84,000 of the closest stars around Earth that we can see from Earth. And if we were to change our exposure, this is what we would see. Now, Curtis, what would happen now if we were to look back down? Now, this is what they would have seen if they were to adjust their pupil and got accustomed to seeing the stars and then look back down. Everything would be so white, so bright, because of the sun's brightness reflecting off the surface of the moon. Now let's change the exposure again, please. Look how beautiful that is, huh? Hey guys, what do you think? Real-time computer graphics with real-time global illumination. Well, there's another conspiracy. This particular question was kind of interesting. Well, it turns out, can we go to the slide, please? When you look at this other iconic image of Buzz stepping on the moon, it's taken from a camera that plops down from the LEM. And it captured Neil Armstrong coming off the ladder, and it captured Buzz Aldrin coming off the ladder. The theory that this photograph was in fact taken on Earth was because some believed, that light source, that really bright light source beyond Buzz was in fact a light that they forgot or somehow mistakenly did not take out of the way when they took this picture. And so if we were to go back to our simulation, in fact, if you were to look at that, well, shucks, that's an interesting question. That's an interesting question. Until, if you were to figure out where Neil Armstrong was standing when he took the other iconic photograph, you'll discover that, lo and behold, there's a white object there. Well, here's the amazing thing. Neil Armstrong's spacesuit is made out of largely Teflon, a material called beta cloth, and it has a reflectivity of about 90%. All the light that hits Neil Armstrong, 90% of it bounces off. Now, you could just imagine how bright the sun is. Without being disrupted by the atmosphere, it lights up Neil Armstrong, and it helped us solve one last unexplained issue when we were working on this project. The one last thing we could never figure out is, why is it that when we compared, and now we've simulated everything to death. We simulate the brightness of the sun, we simulate the reflectivity and the material of the lunar surface. We've captured all of the geometry. We've put all the right materials into the lunar lander, and the lunar lander is reflecting off and also projecting its light on Buzz. We've modeled every little detail. Now, why is it that when we look at it, Buzz still seemed too dark? Well, it wasn't until we modeled Neil Armstrong and we put him in the scene that we were able to see the difference. How about let's turn Neil on and off. Off, on. Off, on. That little tiny detail, and we'll show you in just a second, is so compelling that we now understand why it is that Buzz was lit the way he was. Well, let's take a look at, let's step out and take a look at Neil and what he looks like. There's Neil.
Yeah.
Isn't that beautiful? The extraordinary detail that the engineers put into it is just really, really wonderful to see. And then lastly, let's compare the before and after. If you can go to slides. If you're not sure, the right side is the photograph. The left side is the simulation. What do you guys think? In the example of the Cornell box, I used essentially a photograph to test real-time computer graphics. And we continue to improve its capabilities. We added VXGI, and as a result of that, real-time computer graphics came awfully close to the image that was generated by iRay. Now that we have VXGI, we use the technology, the engineers use the technology to test against a controversial, iconic, seminal photograph.
Something stopped in the past that we wanted to keep it going, but I think I know. Because we didn't.